Okay. I struggled with this one a little bit myself, but I figured it out. So let's take a look at it. It says to test H naught, sigma is equal to 2.2. So sigma is equal to 2.2 versus H1, sigma is greater than 2.2. So sigma is greater than 2.2. A random sample of size n is equal to 19. So n is equal to 19. It's obtained from population that is known to be normally distributed. A, if the sample standard deviation is determined to be 2.3, so S is 2.3, compute the test statistic. Okay. Well, our test statistic, the chi-square is equal to n minus 1 times S squared over sigma squared. And this is sigma naught, which is this right here. Actually, let's try it again. This is sigma naught. Okay. So, we're going to have 19 minus 1 times S, 2.3 squared, over sigma naught, which is 2.2 squared. Okay, so let me see what that gives us. Got 18 times 2.3. Actually, let me do that on the calculator here so you can see it. So I got 18 times 2.3 squared divided by 2.2 squared. Enter. And we get 19.674. Not sure how many decimal places the problem's asking for. Doesn't say right here. Okay. Now this is the part that took me a little bit to get. Let's draw our picture. Greater than on H1 means we're going to have a right tail. And our test statistic, 19.674, right here. And so we're looking for, this is going from 0 up to 19.674. Now this is not our critical value. This is just showing us the area, the probability going up to our test statistic. Well, this is part where I had to find this document. Because in the book I couldn't find anywhere where it even talked about it. But this tells you that we're going to use chi-square CDF, lower bound, upper bound, then degree of freedom. And let's see. We got a right-tailed test, and p-value would be the area to the right of test statistic, or I would have done that one wrong. Okay, try it again. I'm still learning myself on that. Always in my regular class, I am. I do this the classical method, the traditional approach. Okay, the p-value would be the area to the right of the test statistic. Okay, so why does it go up to 200 instead of E99? What I would think is E99 like that. Let's try that. And our degree of freedom, if n is 19, the degree of freedom is 18. Okay. So then, I'll do second vars. I think this is where it's located at. And number 8, our chi-square CDF. And do 19.674 comma E99, so I do second comma 99 comma our degree of freedom, which would be 18. Enter. So then our p-value for there would be 0.3515. Now C, your question says, will the researcher reject the null hypothesis? Well, this is where you're comparing alpha, which is 10%, so alpha is 10%. And then you just compare the p-value against alpha. If you're this here has given us this area right here, and our p-value is 10%, so it would fall over somewhere right here. The tails are a reject region for H0. So since the 10% falls right here and not over on this side, then we would the tails your reject region, so we'd reject H0 or accept H1. Now the second one here, let me see if this is any different. No, you had calculate the p-value were your questions, so you didn't have questions on the other ones. But let's talk about this one, because I want to talk about the different cases in this document. And if you're curious how I got this document, what did I do? I entered in chi-square, p-value, T84, and then it says first one. It's McGraw-Hill, where I found this. And I went and tested it on one out there, and I went higher and tested it on a problem out of 10.4, and it worked fine, except for I didn't read directions where it said round to 3 decimal places. But if it's a left tail test, then p-value would be the area to the left of the test statistic. So it's going to go from 0 up to your test statistic, and then your degree of freedom would be your parameters. We already looked at the right tail test. Now I'm assuming it doesn't really specify where in the world that 200 comes from. Let me see if it says somewhere up above. No, I just pulled it out of the air. Okay, but and like I say, I didn't have right tail test to check this on, but I'm assuming you can put E99 here. But you go from your test statistic then to the right. P-value would be the area to the right of the test statistic. And then again you put in your degree of freedom, which in this case was 60. Values can be much larger than z, so our upper bound in this example was 200. You can always look at the chi-squared again, idea how large to pick your upper bound. Well, I think if you just always chose E99, that'd definitely be the largest you could choose. It's not very clear what they tell you there. Okay, two-tailed test. Do the same as with a right-tailed or left-tailed test, but multiply your answer by 2. And then just recall that for a two-tailed test, that the p-value is the area to the left of the test statistic if the test statistic is on the left. And the p-value is the area to the right of the test statistic if the test statistic is on the right. So I learned something myself today on how to find p-values via the calculator.